So the topic for the today's session will be Introduction to Python for Data Science. And we are honored to welcome Dr. Sharnil Pandya. He is an assistant professor at the Faculty of Science and Environment in Northumbria University, UK. So Dr. Pandya has been actively engaged in teaching research and innovation across the areas such as data science and AI and computational technologies. His research interest also includes the machine learning applications for real world scientific and industrial problems. And he has guided several projects and continues to inspire students and researchers across the globe. And in today's session, he will introduce us to the fundamental of Python and its significance in data science. And we are delighted to have him here today with us. So, sir, please guide us through the learning journey of Python. And I will hand over to you, sir, now.
Thank you so much, ma'am, for warm welcome.
Yes,
Yeah,
sir. Thank you, sir.
uh, yeah, I just need a bit of help how to make the session more interactive. So if you can help me with the audience questions during the session.
Yes, sir.
Sure. So I hope the screen is visible.
Yes, sir. Screen is visible.
Sure. So I think good evening, everyone. And today's topic, actually, we are going to talk about Python for data science. And what I thought was how to cover basic Python, because most of the staff members are faculties, and like most of you are already knowing the basics of Python, and you must have learned during your bachelor's and master's. And so it's very basic. So what I did actually for today's session is I've planned some case studies where we'll discuss a little bit of Python and how we can correlate Python with data science. Right. So I'm going to talk about some of the real world examples, and along with that, we'll learn a bit of Python libraries and then how to apply to different kind of problems. But as I discuss how to make the session more interactive, so feel free to ask any questions rather than it's just a preaching session. It's better we discuss things and for the betterment of our students. So this is my today's agenda. So I'll start with the fundamentals of data science, because it's very important to understand data science before you start the applying different coding libraries to variety of problems. So I always believe that fundamentals has to be correlated with different libraries and it should be applicable to various problems. And some of the case studies I'll discuss the similar concepts. So already I said that feel free to ask any kind of questions and let's make it more interactive rather than just spending 2 hours. You are investing some time. So there should be some key takeaways. So data science begins with data. And first 4 to 5 slides, I'll just revisit some of the fundamentals that we all have studied. So let's recall some of the things, and then slowly we'll take it to the another level, and we'll learn more on the conceptual part, and then we'll move to the coding thing. So it's very simple example. Uh, Humans see a red color, but when we talk about machine, how machine will look at it. So there are multiple ways which we will learn in during HTML, that there might be hex code. It's a combination of RGB, so any color in the world is combination of red, green, and blue. And then everything is understood finally converted into bits and bytes. So everything is in 0, 1. That's how the machine interprets it. If I talk about a particular image, then this is how we look at it. But this is how a particular camera, a motion sensor, can actually look at the same thing. Right. So when the concept of machine learning started, so in 1995, actually Wapnick is the father of machine learning, and then we talk about Geoffrey Hinton. So he actually published first research paper in 1995, and he started talking about how the power of machine learning and support vector machines and different kind of concepts on machine learning. But it was not very successful then because we did not have high computation power. But now we have everything available, and now we can see that AI is actually making a lot of waves. So what is basically machine learning? Everyone is aware. I'll quickly recall. Basically, machine learning predicts future based on the past data. Right? That's the basic definition of machine learning. And what we are going to learn today. So in variety of case studies, we'll basically learn. So we'll talk about data, data pre-processing, So how to remove null values and how to actually pre-process data, how to define different features, how to select features, how to apply them, uh, and like train the model, and based on that how to evaluate the model based on its performance like accuracy or different kind of metrics, and finally how we can actually apply AI into real world. That's the last thing, because a lot of work that we actually carry out on machine learning and deep learning, it's simulation based work. So some of you might be wondering that we get this training accuracy or testing accuracy, but then how we connect this to real world problems. So I'll try to discuss some of the things during the case studies. Now, how machine learning is different from traditional programming. So before I talk about this, if anyone from the audience can actually discuss and try to interpret this figure, that what this figure means actually. So, ma'am, if you can help me, uh, maybe if someone is answering in chat. Hello, ma'am, can you help me? If anyone is answering, so I'll ask a question, and if anybody has answer on to this.
Yes, sir. Uh,
Sure.
just a minute.
So my question was, what is the difference between traditional programming and machine learning or deep learning when we are working with that?
Traditional programming, the input is program, whereas in machine programming, machine learning, output is the program, isn't it?
Yeah. So just to elaborate more, basically in traditional programming, we already know the data, so we give input. We also know the processing, so we carry out processing using different devices, and we get the outcome. But in case of machine learning, we know the data. We also know that what output we want, but we do not know exactly how to process it. That is where the concept of hidden layer actually comes in, and that's what we'll discuss more on this. But as I discussed, that some of the basic things that we have to revisit before we start actually learning, moving to different case studies. Now there are four different parameters. It's extremely important. So this four terminologies, that is actually part of, it's the actual story of data science. So we have learned this during our bachelor's and so many times, but let's try to look at the different perspectives in this. So basically, data is raw facts. We process data to get information, and then we process information finally to generate knowledge. So this is where right now we are at, and we are moving towards wisdom. So that is the final thing: decision making using AI. So as I discussed, that a lot of simulation based work we have carried out. Now it's time that how we can integrate this with real world applications. Example is ChatGPT, and many more models are coming. Also got the news that India is also planning to launch their own model by December, and hopefully it's better. Just like Copilot and ChatGPT and DeepSeek, maybe India will have another level model on this. So these four parameters are extremely important, and we are going to deal with these four things, and the concepts actually revolve around these four things only. So when I talk about data, we actually talk about data pre-processing, data analytics, data prediction, and so on. Right. So whenever we are working with any data science problems, these are some of the common things that has to be taken care of. And if the understanding, uh, ma'am, actually, can you help me? There is some noise coming, so if everyone can mute themselves.
Yes, sir.
Yeah. So these are, even though I'm discussing some theoretical part, but it's very important, because if the understanding of fundamentals is not there, then how good you are in coding while applying to problems or while carrying out research. So as I understand, most of the people are from staff, and some of them are pursuing PhDs, and some of them want to pursue postdocs and so on. So if fundamentals will not discuss and will directly move to the coding, then it's useless, because in future what is going to happen is AI is going to take care of different code. So any errors, anything, AI will take care of. So what is the use of faculties and finally right? How we will play a role. So this is where how we can correlate fundamentals with different problems, and that is where our coexistence actually lies. So this is very important. So any particular problem we take, uh, definitely we have to collect data. So first part is data pre-processing, and there are different techniques for data pre-processing. Some of them we'll discuss during the case studies. Now these steps, it's not necessary to follow in the same sequence, but this is a standard sequence, but you can actually play with this with respect to a particular problem we are taking. So second step is data visualization, where we try to plot data in different forms, let's say scatter plot, line graph, or different kind of forms to understand data. Because there are two very important concepts in the recent times is understanding data and managing data. So those who are good in these two things will definitely survive. So I'm not sure what is happening in India, but uh, if I talk about UK, AI is really taking over. So a lot of people in IT actually have lost their jobs in the last couple of months here. And here a lot of discussion is happening that in next 5 years, so by 2030, there'll be no need of degrees, university degrees, because if skills are not there, those who are actually passing out, then they won't be able to find jobs, and finally at the end, so it's a vicious circle. So finally it will come back to the university. So we discuss a lot and we started a lot of new initiatives now. So we collaborate with industries. So we also have some subject modules like consultancy, where we do consultancy with industries and faculties try to be involved with different things here, because AI is going to really take over a lot of things. But still, there is, as I told you, there is a chance of coexistence with AI, and that is where we need to play our role, right? So these are some of the steps. Then data normalization. So we try to normalize data by applying variety of techniques, which again we'll discuss in the further slides. And finally, we do data analytics, and we may actually so we do prediction based on it's a classification problem, a regression problem, what kind of problem actually we are working with. And so these are some of the normal steps. So we try to define a particular problem. This is extremely important for those actually who are pursuing research or pursuing their PhDs or want to pursue postdoc in the future. So I can give very brief example. There are a lot of people actually they start their research in a particular area during PhD, right? But then while they are publishing their work, they try to publish in different areas. So it's very difficult to build your profile in a particular direction, because you should be now it's the era of specialization. So if you publish just papers in AI or machine learning, it's not going to work. You need to be specialized into a particular area. You should have in-depth knowledge about that particular area, and then you can identify new problems in that area and you can keep on going. And we'll discuss more during further slides, right? So identifying the problems is extremely important, whether it's just implementation problem. So whether just students are working on something, but if a problem that you are actually working on, if you're not really worked on that, then there is no point of doing all other processes, right? Then collecting data. So a lot of data sets are available on platforms like Kaggle. So many universities have their own data sets, so I do my research in healthcare. So we have something called NHS, National Health Services. They also have a collection of data sets available on variety of problems like dementia, Parkinson's, or many more, right? Then it's the same process. You keep on carrying out your data pre-processing. You do data visualization. You carry out exploratory data analysis. You model your data. So finally, you choose that which particular model you want to go for, whether it's a sequential model or different kind of ML or DL model you choose, and accordingly, you actually try to build your model. You train the model. You try to evaluate your model, and finally you try to integrate that with the real world application. As I told you, that is in recent times, that is the challenge. That is where we actually reach, and that is part of the wisdom, the fourth parameter I talk about. So let's move to some case studies. So we discuss some of the theoretical parameters. So what I'll try to do is I'll try to correlate this with some of the case studies. So enough, we actually worked with the slides. Now I want to talk. So as I told you that it's extremely important to identify a problem. So if you're not really identified a good problem, then other steps that we are following up, it's not going to make much sense, right? So if I talk about this in terms of implementation, it is applicable. If I talk about research or any other areas, R&Ds basically. So so what I feel is right now where India is actually lacking. That is actually innovation part. So basically R&Ds. And second thing, what I felt is the training culture is somewhere missing. So research culture and training culture, these two things are extremely important going forward. And that is where even government is paying a lot of attention nowadays, and a lot of discussions are happening on that. So let's come back to the problem. So there is a portal. Actually, this project was started. It's Indian project. Actually, it was started in 2018 and 19. So this particular portal actually can tell you that what is current air quality index. So let's say if you open this particular portal, aqi.in, right? Just you can do this experiment with me. Right. So open this portal and it will actually tell you air quality index around you. Now, this is already, as I told you, since 2018 and 19, this is available. Now, basically air pollution, so air quality index is nothing but it's just a color coding scheme adopted by few countries, which actually classifies this AQI index in terms of the air quality is good, moderate, poor, unhealthy, severe, or hazardous. And then it has some links with the climate change, and basically from where this data is coming. So they have different kind of sensors which is already available. So pollution actually, so air quality is measured by standards such as PM. So particulate matter 10 and 2.5 are the standards. Basically, it captures dust particles from the surrounding environment. Then it uses parameters such as NO2, SO2, ozone, and there are multiple parameters. So correlation of all this, finally, it actually calculates AQI, right? So here the problem is, so whenever you want to identify a good problem, it's very important that you try to understand limitation of the existing system. That's where the research starts. So where implementation stops, research starts from there, right? So now if I talk about limitation of this particular portal, so this can tell you AQI index for today, and not just for this particular location, but you can actually search any city, any location of the world, and this can actually tell you AQI for that particular area. Even let's say if I assume that you are in Modasa, right, around that area, and if you open this portal, it will give you AQI index for that particular area. Now here the limitation is it can give you AQI for today, right? But what if you're planning a trip to somewhere after a week or after 10 days? And just like we do weather forecasting, so we should know weather in advance, that what's going to happen after 10 days. And that's how we plan our trip. In future, in cities like Delhi, this is going to be very important problem, that the prediction of AQI, even though some apps give you some static data, but then that data is not really useful because it's not connected to real world system. And this project is very interesting because it has more than 700 different stations all over India. So station means a combination of multiple sensors connected to controller, and which is connected to platforms such as cloud, Google Firebase or AWS, where the data is stored, and we apply various machine learning and deep learning to actually predict, to calculate this AQI and then classify them into these categories. Now, again, come back to limitation. So as I told you that after 10 days, what would be the AQI index for this particular area is actually missing in this particular project. And that could be, and in future, we can correlate this with something like GPS. So just like we know GPS, and we whenever there is traffic congestion, there are different color coding is actually being applied. So red color means you know that there is a lot of traffic, right? And there are different color coding is applied. Likewise, we might have pollution map in the future, where along with the location, we also should know the actual air quality index value of that particular area, right? So I also give you definition. If some of you want to work on this kind of problem with your students, you can actually work on it. Right. So the coming back to limitation, the prediction this portal can now actually do, and this problem maybe we can take. So I started working on this during 2018-19 when this particular project was launched and it was available. Right. And you can explore this particular portal. It has a lot of very interesting information. As I told you, you can search location of all over the world, and this will give you information on air quality for the particular area. So what I did was this particular case study I took actually for one of my deep learning session. Now, if you go to Kaggle and search L quality data sets, there are many data sets available, right? So already you can use, as I told you, machine learning means you predict the future based on past data, right? So it's the same thing. It's applicable in practical world also. So what I did for my session, actually use some of the files. So let me go back to the case study that I undertook. So we'll use similar example, right? And as I told you already, this data set is already available. So if you search on Kaggle or variety of other platforms, you'll get this data set uh, for particular location, which has its GPS coordinates, date, time is there, and different parameters are there. So as I told you, PM10 and PM2.5, this actually captures dust particles from the surrounding environment and then correlated with CO, O3, NO2. So this can actually talk about, give you a lot of information about air quality in a particular location, right? So this particular uh, sheet has actually this different pollutants along with its AQI values. Now, as I told you, there is no specific formula to calculate AQI because it's more like a color coding scheme. But if you use this parameters along with its AQI values together, if we correlate this, we can actually identify AQI value for a particular location. So we can actually calculate that. And actually, those who are interested in this, I actually published a research paper on air pollution prediction, where I actually talk about how to correlate all these parameters and how we can actually create a formula for AQI. Right. So we'll discuss that later. So let's come back to this particular data that I've gathered. So I already talked about that there are basic parameters and what we are going to do now, because a particular, let's say this particular Excel file you have, CSV file you have, where this kind of data is given. Now, when we start applying machine learning here or deep learning here, or start using different Python libraries, it's very important to first understand data. As I told you in the recent times, there are two important things. If you can understand data and if you can manage data. Now, why to understand data? There are more than 100 machine learning algorithms are there. So let's say if I want to apply machine learning here, we need to know that from that 100 algorithms, which algorithm to choose and apply it to this particular file or particular problem that we are actually undertaking. And likewise, managing data. If there is a large data available, then you need to choose a particular cloud platform or where you want to keep data, how you're going to handle it. So concept of big data analytics, all those things will actually come into play here. Right. So what we'll do is we'll just try to learn some of the Python libraries along with this particular case study. So to make it more interesting, I try to correlate that with a problem. In this particular case, it's air pollution. In future, we'll discuss in other further slides, we'll discuss some other problems, right? So these are some of the common libraries when you want to work with ML and DL. So basic Python syntax, I assume that most of you are already knowing, right? So how to use functions and how to use list and different kind of arrays and how to declare variables and how to use different control structures. Right? It's a very basic thing that I think most of you might be knowing, right? And there are portals available or a couple of Coursera courses where you can just learn this basic thing, right? So we'll focus more on the libraries that we are going to apply to variety of ML and DL related problems. So in this particular case, I'm going to use libraries. So I'm going to use some of the libraries from NumPy, Pandas for data pre-processing, right? For visualization, I'm going to use Matplotlib in this particular case. And then this example, so I actually applied linear regression. And I'll also discuss that why I applied LR here and not other regression algorithms. So I'll discuss that when I discuss some more libraries and the concepts why I'm applying LR here, right? And then I've divided this particular data in terms of training and testing. So I splitted them into two parts, and then we have carried out a little bit of data analysis based on this, right? So let's say now in Python, uh, there is a concept of data frame, and it's extremely important concept when you're working with different problems. So data frame is nothing but you can understand that a particular set of space or memory, right, which is stored. So when I write this particular line, data is equal to, so what is PD? So as I told you, we are going to use libraries such as NumPy and Pandas, and I just given some acronyms as PD and NP. So next time when I want to call Pandas, I don't need to write the entire thing. I can simply write PD dot read CSV. So this particular function can read this particular file, which I was discussing with all of you, right? So it has different locations, then different pollutants, its AQI values, right, for a particular date and time. So I keep on repeating, machine learning predicts future based on the past data. So it's the same thing we are doing. So when you write this particular function, right, it will display this particular file. So data.header will display all the headers of this particular file. So along with headers, it will display the same data that we actually seen. Now, if I just apply some of the other functions of this data frame, if I just write data.shape, it will talk about how many number of rows and columns are there, right? So as per this, it is calculated 35,949 rows are there and 18 different columns are there. Now, it's not necessary that every time in a particular problem you're going to apply, you're going to select each and every column and right, even though you're going to select most of the data, but you're not going to use all the columns. And these columns basically will like term it as parameters, right? So going forward, we'll use machine learning terminologies. So all these different columns has different values of pollutants, AQI values, etc. So we are going to tell this different parameters, or we can use the word here. We can start using the word features here, right? Now there are different functions of pandas available. If I want to identify the length of data, I can simply write length of data, and this will just tell me what is the actual length of the data frame. Now the challenge starts here. So as I told you, once you have data, we cannot directly just start applying machine learning here, or we cannot just start applying different kind of TensorFlow, Keras libraries here. The first step is extremely important that will decide your metrics such as accuracy is data pre-processing. So in this particular file, what I've done is simply I've identified null values and we have just made some attempt to use some functions to remove these null values, right? So as I told you, there are 18 different columns are there. So when I just apply this particular function, so is null, will check number of null values are there. And then finally, it will tell you a list of rows that is available in this particular file, right? So and then what we are going to do is from the total length of data, we are going to deduct null values because those values are useless. It's going to affect your accuracy. Now, dealing with null values, there are different ways. So one way is simply I can use functions such as drop NA and I can just drop all the null values. Another way is we can apply scaling here. So we can just find the average value of a particular column. So let's say this particular column I take and I just take average value and then I can replace null values with that particular average value of this particular column. So mean and the concept of mean and medium will come into play here, right? So this gives me the basic picture or overall picture that how many number of rows are there for particular parameters. So for different 18 columns, I got this basic data. And when I print it, this will tell me that what is the original length of data. That is 35,949 rows. And data after elimination is almost close to 20,000. And the difference is this. So as I told you, we need to clean data. So this process is basically cleaning data. And there are multiple ways are there. There are encoding techniques are also there. Depends on what kind of data you're dealing with. Right. So when we'll discuss more case studies, we'll talk about some of the encoding techniques as well. Right. So this was our step number one. So as I said, if we revisit our slide, now you can try to correlate your theoretical stuff with what we are doing, right? So first step was data pre-processing, right? So we are almost done with this. We have cleaned our data and now our data is ready for applying a variety of data visualization or machine learning algorithms. Now, every time this data will be different. So this particular file, you can see the data was very simple. And what we had done is we just removed null values from this. We just try to identify inconsistent data and we just try to convert this into more machine understandable form. Or you can say that because what will happen is the null values or the inconsistencies that is present in this particular data set is going to affect your overall accuracy at the end. So as I told you, there are multiple techniques are there. So depends on a particular problem you're working with, you're going to select a particular technique during that. So let's come back to, yeah. So the next step is feature selection. Now, as I told you, there are 18 columns are there, but it's not mandatory that every time I have to apply all these features or all these parameters to solve a particular problem. So in this particular case, if I just want to calculate AQI, maybe I'll just keep first three locations. So I can say the location, the GPS coordinates, and date and time. So these three maybe I can skip, and then I can consider this values. So all the pollutant values and its AQI values, and correlate them to actually predict air quality index for that particular location. Other way to look at it is, let's say if I want to select a particular date and time, or if I want to select a particular parameter from this or location, then I can keep that particular parameter during feature selection, and I need to select that particular feature if it is affecting the overall outcome. So feature selection depends on what kind of outcome you're looking for that particular problem, right? So in this particular case, the case study I'm taking, I'm not considering this first three columns. And in Python language, if you want to call this particular column, we'll call it index 0, 1, 2, and so on. Right? That's how we are going to name it while coding. So I'm going to select my values from here. So I'll consider all the pollutant values and its AQI values for my experiment. Right? So there is a function. So what is this data new again? So as you know that we had created a data frame, right? And from this particular data frame, we actually drop null values, right? So what I've done is I've stored this into this new data frame, all the values. So as I told you, data frame is nothing but a memory or space. So when I just call this pd.read csv file function, basically everything that is inside file will be stored in that data frame. Now, as I'm reviewing null values, what I've done is I've created a new data frame with, so without null values, we have considered for this particular feature selection. Now from this particular values, we printed these values, and now we are going to select different features. So this particular function, data new, so it's the data frame dot ilog, it will identify the location. And when I say all, so this column means all. That means I'm going to select all the data, all the 35,000 records it has, and I'm going to select index 3 gem 4 dot values. So whichever column you're looking for, accordingly, you'll start selecting this particular values. So let's say if this particular column I want to select. So if I start from here, then 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I can say 9 gem 10 dot values. That is, this particular column will be selected. And now we are going to talk about, start telling the same thing as features, right? So when I just write this particular function dot values, it's going to select that particular column from that particular file. Likewise, we have done is for all the 5 pollutants starting from NO2, O3. So O3 data, so ozone layer data, we have considered for 1 hour and 4 hours. It's very important while like telling that the air quality for particular location. Then there is carbon monoxide. So CO is there. Then PM10 and PM2.5. So these are the pollution standards. It's standard pollution standards. So when you're working with air pollution related problems, PM10, PM2.5 basically will decide. Uh, so it will actually, so there are two different kind of PM10 and 2.5 sensors are available, and these sensors capture dust particles from the surrounding environment, right? So likewise, we choose the AQI values of all these pollutants, right? And we apply the same function, and randomly, as I was not exactly knowing the final number of rows, so I simply selected 0 colon 60,000. It depends if there are 40,000 records, you'll just write here 40,000, 35,949, and so on, right? So, so basically, this particular process is called feature selection. So from this particular file, we have selected all these features, which is going to affect the overall outcome at the end. So basically, we want to predict air quality prediction based on this particular data. So this was our step number 1. So first step we carried out was data pre-processing. Then we did feature selection. And now, as I told you, this sequence is not mandatory, but this is a standard sequence, but depends on a particular problem you are undertaking. You're going to play with this particular steps. Now, second step is, as I told you, there are more than 100 machine learning algorithms are there. Now, how to decide that which particular algorithm we are going to apply on this particular data set? And that is very challenging thing. And with experience only, you can actually learn that which particular algorithm will be applied here. Correct. From one go, you might be confused that, okay, you might apply different kind of regression algorithms here for this particular kind of data. So the easiest ways, and that's how even data scientists works in companies, that they try to plot data, they try to visualize data using scatter plots or line graphs or bar charts and try to understand data. So as I told you, so I keep on repeating, understanding data and managing data, these two things are extremely important. So in this particular case, so what I did is I use matplot libraries. So matplotlib is the library used for visualization, and I'm plotting here scatter plot for two different values. So NO2 value, so NO2 parameter from this particular file. So this I'm selecting, and just for understanding, I'll just highlight this, and I'm going to select AQI value of this particular file, right? So I'm going to consider NO2 pollutant and its AQI value, right? And I just plot these values, and after plotting, you can realize that this plot looks like, so it's very linear, right? So from this data, as I told you, we need to understand data. And from this data, easily we can understand that here linear regression can be applicable. And there is a good chance that you will get good prediction accuracy for this particular parameter for NO2, right? So simply, as I told you, I use matplotlib libraries. I plot this data for NO2 and we got a linear data. Then again, we try to plot some other parameters. So we take CO and AQ value of CO. And yeah, one thing I want to discuss here is, as I told you, there are multiple problems are there, right? So as a data scientist, it's very important that you have some domain knowledge of that area. Otherwise, you'll again start struggling while applying machine learning and deep learning there, right? So so that's why I tell that it's very important to understand the concept of data science, then understand the problem. So identify the right problem. You should have the background knowledge of that problem, and then you start applying it. Then the other steps we are following is going to make some sense, right? So carbon monoxide is there. So I consider again CO value and EQ value. So again, if I go back to this file, I've considered, and maybe some other color I'll choose, and the EQ value of this particular pollutant. And likewise, we plotted, and again, we got very linear data. So this gives me indication that out of all the regression algorithms, I can choose LR for this particular parameter. And we keep on doing this, right? So now I'm not repeating the same. So already we've discussed that. So same thing we'll do it for O3. Again, we got linear data. We're going to apply that on O3 4 hours. Again, we are getting the similar kind of data. And then PM 2.5 and 10, which are the pollution standards widely adopted all over the world. So we are going to consider those values for PM 2.5. And we can quickly see from whenever I'm plotting this data, the data is linear. So the selection of algorithm that I have decided, it's correct. Sometimes we will make mistakes. So you might choose some other algorithm, but based on visualization, you can understand data and then you can revisit and you can choose different algorithm because that particular algorithm is not giving you good accuracy, right? And then we plotted all the parameters together. So we did some more visualization to understand data. So all this process, why we are doing is just to understand data, right? And then now it's time to model your algorithm, right? And then train your data. So what generally we do in machine learning is we divide your data set into two different parts, training and testing. Generally, it's 1/3. So let's say 70% we keep it for training and 30% for testing. It depends on a particular problem we are taking, and individual may choose differently, 80-20% or 60-40, depends on a particular problem we are taking. And if you're fine with that, so it's random. So it's not mandatory that you follow a particular style for this, that it has to be 70 or 30. It's not like that. You can decide on your own. So you can see here for NO2, I'm considering two parameters, NO2 for training and NO2 variable for testing. And same for AQI. Now, as I told you, I'm going to divide this. So using train test split function, I'm going to divide. So my test size is 1/3, right? So as I told you, you can decide. They want to keep it 70-30, 60-40, right? Whatever you want to select. right? So these are the parameters I've considered. Now, in case of linear regression, there is a concept of scaling. So as I told you that while you're pre-processing data, right, there are multiple techniques available. So there is a concept in linear regression called standard scaler. So if there is a need to scale your values, then you can apply this. But when I did this experiment, I understood that scaling is not giving me good result. So actually I skipped this part, right? So again, depends on data, what kind of data set you're dealing with, you can make this decision, right? So otherwise, this is a standard practice in linear regression that you can apply standard scaler and you can do that. But in my case, it's not required. So simply, I just apply the function. So scalar.fit transform. So this is the function when you want to scale your data. But as I told you, in my case, it's not required. So simply we'll directly move. So we'll start training the data for, so in case of NO2, so NO2 train and AQI NO2 train, and then NO2 test and AQI NO2 test. And then we are going to again visualize this data. We try to plot the data to see that what kind of prediction we're getting. And we also need to identify here outliers, that as we are applying linear regression here, which is more form of linear data, but while we are predicting data, if the data is not actually fitting that and it's going outside, those are called outliers and that has to be removed. Otherwise, it will actually affect your overall accuracy of this particular data, right? So simply I would declare my NO2 LR variable, and here we need to decide that which particular regression algorithm. Now, uh, I think I'm skipping this part, but machine learning problems are generally divided into two categories, right? Supervised and unsupervised. And this kind of problems are regression problems or classification problems, right? So this is very basic information, which I think all the staff is there and you already know this. So I'm not talking about that. So in this case, I'm choosing linear regression based on the visualization that I have applied, right? So our second step was data visualization. So we are done with data pre-processing. We selected features here. So there are some sub processes here. Then data visualization. If required, we'll apply data normalization and then we'll carry out data analytics. But as I told you, this sequence is not mandatory. You can play with this with respect to a particular problem you are undertaking, right? And then we try to score this particular. So we apply LR here and we train this data for different parameters, all the pollutants we are selecting, and then we score it. So we try to predict this based on its NO2 train value and AQI values. And then after training, we are going to test this same values as well, right? So same thing is applicable on different pollutants. And as I told you now, so this is our linear line, as you can clearly see, right? And when I try to plot this data for NO2, you can see that most of the data belong to this particular line. But there is a possibility that some data will not belong to this line and it will be somewhere here, here, scattered here data. And this kind of data is called outliers and that has to be removed. That cannot be considered for the final prediction, right? So we keep on doing the same process for all the other parameters. So we'll do the same for CO. So again, we declare our linear regression variable for CO, right? We train this particular parameter, right? So using CO train and AQS CO train. And then we try to score this model. And you can see that we are getting good accuracy in this particular case. And again, we try to plot the data, right? So we'll follow the same process now for all the remaining parameters. So I'm not repeating the process because already we've discussed. We plot the data. We'll try to remove outliers if it is there, and we'll keep on doing this. So we'll do it for O3 1 hour, 4 hour, and then PM 2.5 and PM 10. Right. So this is our hypothetical line, and accordingly, we are just plotting this data. Now, when you're dealing with linear regression, for all these parameters, I need to actually know the weights. And if you want to print the weights, so this is how you can actually do it. So So these are the different coefficient actually. So what is happening here is, if I go back to this particular screen, so as I told you that AQI index is nothing but a color coding scheme adopted by various countries. Right? So there is no specific formula to calculate AQI. But for this particular case study, right, based on the literature review and everything, what I did is actually I have actually created a formula for AQI. So all these things are actually coming from there. So those who are interested can, yeah. So there is a research paper available on this. And where I actually talk about in detail about how to calculate AQI and actually discuss the formula in this particular work. Yeah, I can quickly talk about, right. So why this coefficient and everything is coming, right. So in this research paper, actually I have designed a customized formula to predict AQI coefficient for the particular parameter. And finally, we are going to add. So this is the final formula for Y predicted, where for all the parameters, we're going to apply this particular formula to calculate AQI. Right. So there is no fixed AQI index is available, but based on the literature and whatever information I got, I defined my own formula. And based on that, I actually calculated AQI for that. Right. So that's how these coefficients are coming. So as I told you, when you work with a particular problem, it's also important to have some domain knowledge or the background of that particular problem. Right. So that's how we calculated coefficients for each and every parameters. And then based on that, we calculated AQI value for that particular location. Right. So because combiningly all these parameters together, pollutant values as well as its AQI values, based on my formula, it's going to give me air quality index. And that's how this air quality index is actually calculated. And this is already, as I told you, there is no specific formula is available. So I defined my own formula based on the literature, everything. And that's how finally we are going to classify this into these categories of good, moderate, poor, unhealthy, etc. Right. So this was one case study on air pollution, right, where how we can actually apply to a particular data set of air quality index data, where its pollutants and its AQI values are given, how we can correlate that, and then finally predict the value. So if I try to make more sense on this, what basically we can do is, so this particular area, how I actually worked on is, as I told you, different sensors are available which will capture data for particular location. So there is indoor monitoring pollution station is there and outdoor. And in the similar fashion, this particular portal is also working where different stations all over India are placed, which is capturing this data. So it's following this particular process where this data is captured using sensors, right? It's stored on cloud, and then we apply machine learning and deep learning there based on the data. And then we perform all these steps, data pre-processing, visualization for the final prediction. And in a simple layman language, basically, if I consider date and time values here, simply I can select a date here, and machine learning can actually predict future based on the past data. So that thing can happen here, and this will give value. So this will give information related to particular date, right, for all the pollutants that we are selecting and the air quality index values, right? So a mobile app was also designed which will give you AQI values as well as individual parameter values of that particular location. However, even though I got success in this, but there is a limitation with even this system as well. Because what happens with sensor is wherever you're placing your pollution station, it will only give you pollution of that particular area. Let's say if I take about Modasa, particular area of Modasa where your university is, then this will only give you pollution air quality index for that particular area. Based on that, you can't tell that for the entire Modasa, the same index is applicable. So that is another challenge where a lot of different kind of research people are carrying out. So they're putting this pollution station on the car, and then they're moving. So they're moving car for let's say 5 kilometers, and every 1 kilometer, after every 1 kilometer, we're capturing data and trying to find the average of that particular area. And so that's how people are carrying out different kind of researches on this. If you're more interested in this particular area, then a couple of research papers are there where this kind of pollution case study I will discuss already. right? If you read this research paper in detail, I've discussed almost 40 pages. Research paper is there where everything in detail I've discussed that how this thing is actually working, right? And this particular paper actually I published with some bachelor students. So we work together on this particular project to carry out this particular experimental work. Now let's move to another case study. Right. So this was about how we can take a particular problem and then how we can apply a basic machine learning algorithm such as linear regression and use different kind of TensorFlow and Keras libraries as well as some NumPy and Pandas libraries for data pre-processing and how we can actually work with that. Now another example I'm going to take about it's a very common example that some of you might be knowing already, but as we are following fundamental, it's very important to discuss this example as well. So another case study is on ANN. Now, when I discuss the traditional programming model and ML model, right, we talk about one thing that in case of traditional programming, we give the input, we process it, and we get the outcome. But in case of machine learning, we know the input, we know the outcome as well. But what we do not know is the processing. And that's how this is divided into three layers: input layer, output layer. But as I told you, these two things we already know. But what we don't know is the processing, and that's why it's called hidden layer. And that's how any machine learning based particular project, if you are working on, that the thing that you need to really work out is the hidden part or how to process this, because you need to deal with different kind of data. There could be multimodal data. I'll take another example: how to work with audio. So if there is a MP wave file, so MP3 file or wave file you want to work with, then how we can actually apply machine learning there. So that is my actual area of research where I actually work on apply acoustics on various healthcare issues to identify the problem. Right. So now this is very simple example of face neuron. Right. So as I told you that when we look at particular image, this is how we look at it. But if I talk about a neuron that is part of a entire artificial neural network, then this is somewhere how. But basically, this is also not true. Basically, everything is converted into 0 and 1 for the machine to understand. Right. So these are some other examples. So mathematically, how that thing is working. So before I talk about deep learning example, it's very important to understand the concept of deep learning, how it's actually working. Because what I discuss is we know the input, we know the output as well, but what we don't know is the processing. And we are going to understand how that is actually working. So basically, we can say that we are giving input, right, into neurons as, so we are giving different weights as input. Assume that your algorithm is one function called fx, where I'm giving certain inputs, right? So these are random inputs I'm giving because I already know the input. So I have these inputs available. So this way I'll call it weights. I term it as weights as input, and I also know the outcome that I want, but we do not know that what is happening in between. And that's what we need to figure out. And how the concept of deep learning machine learning works here is we give random input, random weights here. This goes into a particular function fx, and finally it calculates the value. So assuming that this is binary classification problem, so we have two classes, 0 and 1, right? So basically we want outcome 1 or 0, right? Accordingly, so I'm going to give some weights here, right? So we initialize with random weights, we initialize NN with random weights, and let's say I got the outcome 0.8, but what we are looking for is 1, right? So we keep on changing these weights until we reach close to 1 or the outcome 1. That's how this thing works. So that's how the concept of hidden layer or the hidden processing actually works, right? So we keep on doing this. This is not easy. So we keep on adjusting weights, and there are different techniques available to again adjust weights and so bias and variance. There are multiple concepts are there in this, right? So this is how you train your model, and finally you try to get to the close outcome which you're looking for, right? If required, there is a learning. So you need to fix your problem, which is called fine tuning in machine learning. So fine tune your process, you fine tune your code, you keep on doing this till you get the required result. So in terms of accuracy, if I say that whenever we go beyond 95%, right, then you can say that you have good accuracy. Again, as I told you, it's a simulation accuracy. So 95% accuracy, if you get in your algorithm, it's not your actual accuracy. So when you connect to real-time system, that accuracy will be deteriorated by 15 to 20%. Right. So that's how you keep on working when you work with machine learning and deep learning problems. Now taken one computer vision example here. Uh, as I told you, it's a basic example. Some of you might be knowing already. So I'll quickly discuss that. So it's handwriting recognition. So you can see there are digits 0 to 9, right? And this we want to train it with ANN model. And at the end, we want to predict this particular digit out of 0 to 9. Now, how machine learning or deep learning algorithm works actually? So so if we revisit the concept of NN, then basically it mimics our brain, right? So basically, if I come back to human body, your brain is actually connected to different neurons throughout your body, right? And finally, it sends signal to different parts of the body, and that's how it works. So when we were very small in a school, how we were studying these digits, right? So we were studying slanting line, sleeping line, standing line, etc. And in the similar fashion, we to make the machine learn, right? So this example is actually talking about the same thing. Let's say 9 in this case I'm considering. So what I have to do from 0 to 9 is I need to find that how many digits have sleeping line, standing line, slanting line, and circles. And based on that, I can try to classify this number of digits. So example is this. From 0 to 9, let's say, let me find a cluster with vertical lines. So whichever digits has vertical lines, I can put, let's say in this case, 1, 4, and 9 into one cluster. So this is one classification I got. Now based on the horizontal lines, again, I can choose some of the digits, let's 2, 7, etc. 0 can even be fitting in circles. And then we try to find digits which are small circles, right? So that's how we can make the machine learn. Just like we've studied in school, in the similar fashion, we need to make the machine learn the same thing, right? So basically, all this standing line, sleeping line, slanting line will learn, and circles will make the machine learning model learn. And finally, we'll try to predict the outcome as one. And that is the entire process we need to carry out. So in this particular example, I've taken example of MNIST. It's already available. MNIST handwriting dataset available on Kaggle, very well known. And we'll just try to understand the process of deep learning. And then along with that, we try to understand some of the TensorFlow and Keras libraries to how to apply to this particular problem. So what we have done is we have considered 28 cross 28 images of different digits from 0 to 9 in this particular case. Now, while you are building your model, you need to choose, and in this particular case, your model is sequential. So we'll simply write model is equal to sequential. Once I'm done explaining the coding part along with the fundamentals, we'll again go back to Google Colab, right? And we'll try to understand more in like uh, more technical point, just the coding point of view. But currently, it's very important to understand and correlate fundamentals with these libraries, right? Now, in this particular sequential model which I have selected, now you also need to decide yourself that how many hidden layers you want in for this particular problem. So every problem is different, and that's how you're going to choose your input, hidden layers, and outcome. But most of the time, you'll know your input, you know your outcome, you do not know the hidden layer or the hidden processing that is happening here. So in this particular case, what I've done is I have actually, so I'm going to add two layers, which is 500 neurons. So again, this is random value which we are going to choose. So initially you may choose 250 or 700 or 800. But if you're not getting the right outcome, you can keep on adjusting this. We call it fine tuning, right? So in this particular case, I'm using this function called model.add. I'm choosing dense layer here in this particular case. So there is a flattened layer, dense layer. There are different layers are available, right? So in this case, I'm considering dense layer. My input dimension is 28 cross 28. So these are 0 to 9, 28 cross 28 images. And number of neurons I'm selecting is 500. And the activation function in this particular case, I'm selecting sigmoid. So there are multiple activation functions are there. And already I discussed that fx. So activation function works in the similar fashion. Right? So there is a function like softmax, sigmoid. There are multiple activation functions are there, which you are going to choose as per the, again, based on the requirement and the problem. Uh, One of the advantage of sigmoid I can say is if you have negative data in your data set, then sigmoid can actually deal with this because it is 1 upon 1 plus e raised to minus x. So when you apply this particular activation function, you can even deal with negative data if it is present in your data set, right? As I told you, there are multiple options are there. So you can select ReLU, 10H, soft sign, soft plus, sigmoid, linear, etc. So there are multiple options are there. It has its own significance, and based on the problem, you're going to select a particular activation function. Again, we are adding one more layer. Again, it's random. As I told you, there is no fixed pipeline to follow here. So randomly we choose based on your experience, you learn that how many neurons you need. And uh, generally it's always we try to select power of 2 raised to n, but it's not mandatory. But that is how most of the standard case studies are followed. But you can choose 200, 300, like whatever you want. But as I told you, it's more fitting when it's 2 raised to power n. Now again, we are following the same process. So we add a layer with 500 neurons and the activation function we selected is sigma. At the end, so we have one input layer in this case, you can see, which is 28 cross 28 images. Then we have two hidden layers in this particular case. And then we have the output layer. So now in this case, how to decide how many output neurons you need? So if I talk about this particular problem, we are classifying 0 to 9 digits, right? So how many outcomes we are going to get at the end? Whether outcome would be 0, 1, 2, so on to 9. So there are 10 different outcomes possible. That's why we are selecting here 10 neurons as the outcome. And the activation function we are going to select here is softmax. Generally, softmax is the go-to function we go for. Okay, so we are done with creating a model. So we built a model, but now we need to train this using MNIST dataset. That is the next step. So based on this, as I told you, we need to carry out that fine tuning process. So you might have selected initially 700 neurons, 800 neurons. You keep on changing this finally to reach to the stage of goodness of a particular function fx that you are going to select. So basically you want to minimize your loss and you want to get the maximum accuracy possible, right? So now we're going to compile our model. So while compiling, you need to choose your loss function. So there are multiple options are available. So in this particular case, we are going to apply categorical cross entropy. Every loss function has its own significance. So again, based on the problem, we are going to select a particular loss function. Most of the time, we are going to choose Adam as optimizer. There are NADM and there are other options are also available. But most of the problems, we are going to select Adam because that gives you better optimized outcome, which you're looking for. And the matrix, so there are multiple metrics available, but more accuracy is the most go-to matrix that we choose while we work with deep learning. Right. So we are done with building a model. We compile our model, and now it's time. So these are some more options are there. So SGD is there, Adam is there, NADM is there, AdamX is there. There are multiple activation functions available for the output layer. Now using the function called model.fit, we are going to train with 28 cross 28 images in this particular case. So this is your number of images, the labels. Now this batch size is optional, that you want to train this in the batch size of 100, or if you don't give this option, it's fine. And then how many number of rounds you want to train this model. So generally epoch, so number of epoch again depends on the problem. But when there are more epochs are there, there's a good chance of you are going to get better accuracy in this case. However, there are issues that you need to deal with while doing this. Right. So after training, so this X is nothing but it's a NumPy array. Same with this. Now we need to train our neural network model. So once that training is done, now we're going to evaluate our model. So as I told you, we divide our data set into two parts, training and testing. So there are training parameters and there are testing parameters. So in this case, X test and Y test. And using these parameters, we're going to evaluate our model that what kind of accuracy we are getting for this particular, and we're going to print value of accuracy as well as loss in this particular case. And finally, using model.predict, we are going to validate our model that whatever model we have built, whatever parameters we have chosen, everything is fine and what kind of prediction result it's giving us at that, right? So as I told you, this batch is not mandatory, but you can even train your model in terms of batches. In this particular case, we have selected 100. Again, it's random. You can decide, and it's optional as well. So if I come back here, right, this batch size is not actually mandatory option. But if you train in batches, there is a good chance that you can get better accuracy. Okay. Right. So again, this number of epochs you're going to select based on the data that you're dealing with, a particular problem you're dealing with. Accordingly, you're going to choose. Right. So, and there's forward pass and all this kind of operation will happen at the end. So backward propagation is one of the concept that is applied in deep learning, right? That you already might be knowing. And that's how this will be processed at that. So I'll not discuss the theory much, and we'll move back to the coding example that I've taken for handwriting recognition. Right, so MNIST is a standard data set which is already available. So if you just write this line from keras.datasets import MNIST, this data set will be loaded. But if it's not, because sometimes you might be dealing with data which is not available online and you have created your customized data set, then you have to give that particular path, and that's how you're going to select it. So in this particular case, we are going to use TensorFlow, and again we are term as TF. So whenever I'm going to call TensorFlow libraries, I'm going to use TF dot and then particular library. Matplotlib we'll use for visualization, and then some more Keras libraries will use it. And so keras.utils and keras.datasets, and we're going to import MNIST from here. And what we have done is simply we divided this into training and testing parameters. So X train and Y train and X test and Y test. So these are training and testing parameters. And we're going to load this MNIST data here. Now, when I'm going to print this particular data, it's in terms of NumPy array, as we discussed already when we were discussing the slides. So when I simply write plot.imshow, and when I print X train, now what is this 0? 0 is the index value for the particular image. So there might be 50,000 images. So you start from 0 to, let's say, 49,999. That's how you pass on this particular value, and it will actually print that particular image in terms of array. Right. So, right. So when you print X train 0, it will print like this. When I use this function called imshow, then you can see the same value. So it's NumPy array for 5. So number 5 digit is actually printed here. Right. And if I want to convert this into black and white, I simply apply plot.cm.binary, and the same value will be converted into black and white. Right. Now we have our xtrain and xtest parameters. So we use TensorFlow library. So tf.keras utils.normalize. So we normalize value for xtrain and we pass on the axis. So this depends on that. This is a computer vision problem. It's a two-dimensional problem. So that's how you're going to choose your algorithm. So example is, let's say if you're applying CNN with two-dimensional data, then it's called 2D CNN. Right? Likewise, depends on a particular problem and the dimension of data you're dealing with, you're going to choose this particular value. So we are done with this part. Now we can build our model. So again, we need a sequential model in this particular case. So simply we've written model equal to tf.keras.models.sequential. Now we're selecting our input layer as flat layer. So that's why we've written tf.keras.layers.flatten. There is what is this flatten and the layers I'm talking about? Basically, these are the fundamentals of CNN, right? Or these are the fundamentals of any neural network, right? So you need to know little bit of theory as I keep on again revisiting, because those fundamentals are very important while coding as well. as I told you, if you already know coding, but if you do not know the fundamentals, it's very difficult for you to deal with different kind of machine learning based problems. Right. Now we have two hidden layers in this particular case, and we're selecting neuron as 128. And for this particular case, we are selecting activation function as ReLU. So every activation function has its own significance. ReLU is a very go-to function most of the times. Sigmoid, again, you can apply here. The significance of sigmoid is when you're dealing with negative kind of data, it will give you good results. Right. And then we have one output layer. And as you know that how many outcome neuron we need. So that's 10. It's already fixed 0 to 9. So 10 different outcomes are possible. And the activation function we are selecting here is softmax. So same thing we already discussed during slides. And then we compile our model. So we select the optimizer as Adam. And the loss function we select is it's a sparse data. So sparse categorical cross entropy we selected. And the model validation metric we are selecting as accuracy. Now using the model.fit function, we're going to train our X train and Y train, and then we are going to validate this using X test and Y test. Right. So we have simply I've selected 3 epochs in this case. And I can run this also if you want to see the process, but simply we just run this epochs, and for at the end of every epoch, what is the accuracy we are getting and the loss percentage. So you can see that when we are running first round, so when we are training the model for the first round, the accuracy is 86% and loss is 0.46. And when number of rounds are increasing, you can see it's increasing the accuracy. Right. Now using model.evaluate function, we are going to validate our model while passing X test and Y test parameters. And while validating it, it gives us 96.82, which is a good accuracy and very less loss percentage in this particular case. Right. So this is an example, a basic example of handwriting recognition. Now, before I move on to another example, what I can discuss is because these are a little bit what I've discussed is already because machine learning and deep learning concepts are there since last 10 years. That's even though it was discussed in 1995, but after 2010 only actually people started taking it more seriously. We had high configuration devices were available where actually we can apply it. But in the recent times, these areas have changed. So now if you just write a research paper using machine learning and deep learning, it's extremely difficult to publish it because now we have very advanced algorithms are available and we have different kind of problems are available where the approach of using machine learning deep learning has changed a lot and some new libraries have come. So I'm going to discuss another case study which is very interesting one. So during 2021-22 actually I worked on this particular case study. So how to, if you have, let's say, multimodal kind of data, or let's say audio data, then how to apply machine learning or how to apply our traditional ML and DL algorithms there? Because it's very challenging here. Because if you're just dealing with computer vision or basic images, 2D and 3D data, or the other kind of things, or algorithms like YOLO, where you just want to do object detection, it's fine. But when it becomes multimodal, when you deal with audios, videos, this kind of data, that becomes extremely challenging. So during 2019-20, there were new libraries were introduced called Librosa. So before I talk about this case study, what I'll do is I'll give you some briefing on what is Librosa. So Librosa has some correlation with digital signal processing. So basically, when you want to process audio, audio is nothing but a signal, and signal is a combination of frequency or time, right? And it is amplitude and phase, right? So any signal will have this kind of parameters. So these libraries were introduced because before this, it was very difficult to deal with techniques such as STFT, short form Fourier transforms, and different kind of digital signal processing techniques. So we had to apply those, and then whatever outcome we get, we need to apply it to machine learning. But after introduction of Librosa, it has become very easy. Nowadays, even there is a library called Whisper is available when you want to work with variety of acoustics. And recently, companies like Apple and some of the other IT companies have actually started hiring acoustic engineers who can actually deal with audio data. So this is a very interesting and new area where a lot of research is happening currently. So this is nothing but this is actually these libraries are code snippets of digital signal processing techniques. So let's say if I select, and I'll discuss this little later, but I'll simply select, let's say, particular parameter that I want to apply here. So this parameter actually technically is called filters. So when you are dealing with signal processing, you need to apply different kind of filters to get a particular outcome. So you can see here, small code snippets are given and for different kind of filters. And this information, actually, you need to read this libraries and get more information. I'll discuss a couple of case studies on this to get more idea that how this kind of libraries are actually being applied. Maybe we can take one demo itself to understand more. So before I discuss this code, let's do one thing. Let me select a particular audio file and try to process this using this Librosa, and then we'll discuss more that how that thing is actually working. So let me select. So generally MP3 or WAV files are basically work with this. So let me find if I can. Yeah. So it is here somewhere. Yeah. So I'm currently selecting random file. I'll not discuss the case study now, but we are just selecting any random file. So let's say if I consider, because I've selected here water noise, so I'm selecting the same wave file in this particular case. And then I'll tell that what is this and what we are exactly doing. Right. So I've selected a particular file. Now, whenever you are dealing with computer vision or when you are dealing with image, what we do generally is we convert image into grayscale form and then we apply different kind of mathematical functions there. The audio or video also works in the similar fashion. So if I talk about acoustics or audio here, a wave file, it's nothing but a wavelet form, right, of a signal. So I actually recorded noise of water. So when water is flowing, that noise actually I've recorded using microphone sensor. And if I try to process this particular noise, let's see what happens. So it takes some time because you are actually computing an audio file, right? So which requires little high computing as well, even though we are running this on Google server. But you can see, so this is nothing but a grayscale image of audio. Just like we converted, if you remember that digit while discussing handwriting recognition, we converted 0 and 1, right, into black and white. Likewise, for a particular audio file, you can see we converted that into form of audios. So this is called spectrogram, which is nothing but grayscale image of audio. And what it represents is, so it represents hertz, so it's frequency in dBs, you can see. But the problem here is you can't easily interpret this file. So you can't easily, you can only understand this. Here frequency components are high and here it's bit low. That's it. But you're not getting more information from this. So for this, to get more information from this particular file, you have to apply different filters here to extract that information. And those filters actually, so there are more than 150 filters available on this library. And you need to know, so you need to select these filters based on a particular problem you are undertaking. So now we'll discuss more on this once I discuss the case study and what exactly we are doing. So in 2021-22, I started working on a case study where what I wanted to do was I want to capture or I wanted to capture ignorant noises that is happening in a house. So let's say there is a noise of water leakage somewhere, right? So there is water leakage, there is flush water leakage, there is a gas leakage somewhere, because all this leakage is nothing but it's a signal, right? So signal can be computed using Librosa and then we can apply machine learning there. Previously, we used to apply digital signal processing, but we were not able to apply machine learning directly there. But using these libraries, now this is possible. So I have actually recorded noises of 22 different events. So tap water leakage is one event, likewise flush water leakage, radio noise, television noise, chair noise, curtain noise, cupboard noise, and different kind of noises actually I've recorded, and I've created a customized data set for this particular problem. So what actually I'm looking to do here? Basically, I want to correlate these noises with different kind of events. If you are not present at your home and if there is a gas leakage, there is a chance of an accident happening. But what if we capture this particular noise and correlate that with particular event, and if we notify the house member, then we can actually protect our house from this kind of accidents. So that was the idea. So basically, we can use different kind of acoustic events and then correlate with different kind of events. So I designed my customized framework, uh, LSTM CNN based framework, which can be applicable to multiple areas, which I'll discuss later. Right. So this was the problem. So before this work, only one data set was available on audio, that is called ESC50, but which is bird noise and aeroplane noise and different kind of noises are there. But for my case study and my experiment, I wanted a particular set of noises, and that's why I created my own data set. And as these are unknown events, we don't really, these are ignorant events, and we don't really, because we are very busy in our life and we don't really focus on this kind of noises that is happening at our house. But these noises can be correlated with events which will be really helpful to identify event like gas leakage and protect your house. Likewise, electricity, water, and gas are very critical resources, and we can actually save water and electricity using this kind of event. So even I applied this to healthcare. So as I told you, this is a customized model which can be applicable to 100 different case studies. Right. So this was the idea. And using microphone sensors, I actually capture these noises because there was no data set available. I created my own data set. And those who are interested in knowing more about this particular case study, what I can do is I can simply share link of my research paper, or I'll just show you that if you just write ambient acoustic framework and my name, you'll find this research paper. Right. And it was also published in a good journal. Right. So there are some security things are there. So yeah. Right. So it's a good journal. It actually publishes work that is on advanced engineering. So as you can see that working with acoustics is very challenging, and then solving a particular problem by applying machine learning and signal processing together was a novelty in this particular work. So that's how I wrote this particular work. And this journal is a very well-known journal. As you can see, it has impact factor is close to 10. Right. So this kind of work, if you want to publish, and I generally prefer doing my own experiments and then based on that writing the case study and publishing the results. Right. So this work, if you're interested in the entire process and how it started and the series of the entire thing, I've written in this particular research paper. So let's come back to what we are doing. Right. So this example, as you've seen on water noise, right? Now you cannot understand anything from this particular image. So you have to apply different kind of filters here. Now, as I told you, there are more than 150 filters are there in this particular library. So these filters, you have to apply 4 to 5 filters at least to get more information from this particular audios and then correlate that with your algorithm. So let's say in this particular case, I've selected a filter called polygram. Again, for this kind of problem, you need to have some knowledge of digital signal processing and some of the techniques such as STFT and short-term Fourier transform, etc. So what this filter does is this gives me information. It's called two-class classification. So it gives me information of the signal in terms of quadratic, linear, and constant form. Right. So these 3 different forms it can give you information. Then there is another filter. So as I told you, there are 150 filters, and you have to choose different filters, and you have to have some basic knowledge of these filters. So I applied another filter called tempogram. So this library is nothing but it's a music library, and it actually deals with various music parameters of audio. So generally a signal or audio can be measured using its tempo value. So this tempo value talks about its strength of that signal, because if strength is not good, there is a good chance that you will not get good accuracy at the end. Right. So this tempo value signifies the onset strength of that particular audio, because when you're training your machine learning model, it's very important to decide which samples you want to keep and which samples you want to discard. That's how it works, right? So this particular filter gives you this information, and then you can apply some more filters to get the right information about those audios, and then at the end you can train your model. So if I go back simply, right? So this is an example. Actually, I've designed my CNN model, right, to process this kind of audio files. So this example is already given here. So what I've actually done is to make it more simpler. Yeah, right. So using microphone sensors, I've created my customized data set. And what is my research problem here is, or the problem that I've undertaken is, I want to classify all these noises and correlate them with activities such as water, gas, electricity, etc. So these are the different events which I want to capture. Again, the same process we're going to follow. So feature selection will do, right? So in this particular case, I've designed customized LSTM CNN based model. So I train this model using all this data that I've captured. And as I told you that this kind of events can actually help you in multiple domains, such as healthcare monitoring. So let's say is if someone is making noise at midnight for 4 days a week, right? If I talk about elderly person, then I can tell that that person is not having a regular lifestyle, because not taking enough sleep. So this is an example that how this kind of events can correlate with health monitoring. Likewise, nutrition monitoring, safety monitoring. So there are hundreds of applications possible with this kind of. So I designed my customized model, which can be applicable to multiple areas, right? And then this was the process I followed. So I detected audio. Now you know that audio has always some noise. And whenever you collect audio samples, it has different length. And CNN has one limitation, that you have to apply normalization. Different kind of length will give you different kind of bad results and sometimes errors also. Right. So what I did is I normalize all these images, and then so up to 7-second images or audio images I got. And then to remove noise, I apply LBP, local binary pattern algorithm, to these samples, and then I train LSTM CNN based model using all these samples, and find it to classify them into activities such as tap water leakage, flush water leakage, shower leakage, etc. Right. So these are the examples of spectrograms. So these are 5 spectrograms of events such as tap water, flush water, freeze, opening, closing, and chair movement. Right. So likewise, I considered 22 different events. Then I apply different filters to get more information on this. And all these code snippets are already available in Librosa. And like Librosa, there is another library called Whisper, and then there are other libraries. And you might be seeing lot of new gadgets. Apple gadgets or switch gears has a lot of audio-based features, which also uses machine learning. So these are the libraries that is actually applicable there, right? Then I apply tempogram to get tempo values on this particular audios to identify its strength. And then we apply texture. So we convert this into texture form like this. So basically, this is called noise robust images of this spectrogram. So the same thing I can show you on Google Colab as well to get more idea. Now you might be wondering that you should have some background knowledge about that. So definitely it's true that when you're dealing with this kind of things, you need to have some background knowledge of that particular problem you undertaken. That's why it's not just about coding. It's also about which problem you're selecting and the domain knowledge you have about that particular problem. Right. So in this case, you can see these are the spectrograms which we have executed of 22 different activities. Right. And I, using this LBP algorithm, I've converted this into texture form. So these are nothing. Basically, every audio has noise, and noise will affect your accuracy. So we have removed noise using this particular algorithm in this particular case. And these acoustics are extremely important. This can be applicable. So currently, one of the project at Europe I was working on during my postdoc, where actually I detected normal and abnormal heartbeats using sound. So this is extremely powerful library. It's not just detecting ignorant noises at home. This can do multiple things. Right. So it's not possible to cover everything in this session, but I'll just discuss the basics. and then you can take it forward from there. Okay, after this, so basically what we did, this was our audio file. We converted into grayscale image, and then we remove noise and convert it into this texture form, right? And then we train this using LSTM CNN based model. And then based on the location, we classified with that particular, correlate that with particular event. So already I discussed events such as tap water leakage, flush water leakage, right? Based on different kind of noise. Let's say you are not at home, intruder has arrived and trying to do robbery at your home, right? Using this kind of sensor based on the cupboard noise or any kind of noise, this event can be detected and notify the house member, and we can actually protect your house again. Right, so that was the idea, that designing a customized framework can be applicable to multiple problems. And this is how. So I got almost close to 77% accuracy without augmentation, and with augmentation is close to 90%. Augmentation is we are just generating the same samples again because I had less small sample size so that I can get better accuracy. And then I tested this using with noise and without noise using LBP algorithm for all this different 22 different activities. I got this kind of accuracy for LSTM CNN, and then I also compared with some of the other customized machine learning and deep learning models. Right. So this was about audio. So I'm almost done with my session. I'm happy to answer if any other kind of questions are there. Uh, I know that I discussed a lot of different kind of case studies and concepts, but I'm happy to discuss anything if anybody has any questions. Yes.
Thank you, sir, for your nice presentation. I am Dr. Nilesh Baltare from GEC Modasa.
Hello.
We have also some reputed publication in air quality, and we are looking forward to take help from you for further research. Um, uh, One of my question is about frequency domains. So you have
Yes.
talked about some frequency means Fourier transform and other techniques
Techniques.
for
Yeah.
frequency domain analysis. So, from your perspective, what will be the future of machine learning, deep learning in case of air quality, if we think from perspective from frequency domain?
Definitely, it's a good future because we are still struggling with similar problem in Delhi, right? We have tried different kind of machines and different kind of things, but it's not working. And this is going to increase because we hear a lot about climate change, right? So in future, so if I talk about, let's say, UK, here what used to happen was it used to be cold till certain months, and then but it has changed now. That pattern has completely changed. So climate change is actually taking a lot of effect here. So it's going to, so the area you selected is really good because sustainability is the future keyword. So when we look at UN sustainable goals, then achieving sustainability and climate change is an extremely important parameter going forward. So there are many problems in that area that you actually chosen, and there are some challenges also, uh, as
Yes,
I discussed during the case study also.
yes, sir. And my second question is, what is the recent state of art work from your perspective, which is highly effective in domain of air quality and also in acoustic um detection? Means
So
what-
yeah, so one work as I discussed, I actually carried out. I can show you that. So actually, I worked on a project called Horizon. Some of you might be already knowing Horizon 2020 is a very prestigious EU project, right? And even those who are interested in pursuing postdocs, let's say, there is a fellowship called Marie Curie, which every year once you can apply, and you have to compete with researchers from other countries, and you have to submit a research proposal, and based on that you can select. So if I'll show you that project quickly, it's that link is there on my LinkedIn. So what exactly I did was, so this was my postdoc project actually, and I work with uh, actually normal and abnormal heart sound. So Now, why this particular project I was working? So the question you ask. So this actually I started in 2019 because and the reason was we hear a lot of incidents that is happening around us, and my interest is always identifying limitation of the existing system and how we can solve that particular problem using research or whatever knowledge we have. So in this particular case, what was happening was we hear a lot of incidents. Now you need to reach hospital to diagnose yourself. So there should be, I mean, you need ECG machine. And ECG machine, if I talk about INR, it costs you 10 lakh, right? It starts from 7 to 8 lakhs to the range is very high. So a common man cannot afford that. So my idea was that how we can proactively detect the abnormality or just the possibility of cardiac arrest, even though we are not medical experts. But if we can apply technology and get some information, just like we process audios and try to get some information, then we can tell at least that person that you need to get the diagnosis done because there is a possibility that something might happen. So AI and I mean, the computer science graduates can really play a role here, along with medical experts together as assistive technology to solve this kind of problems. Because right now there is no solution available for this kind of problem. And this was the reason actually I applied this, and actually I almost received 2,22,000 euro fund for this particular project. And currently I'm working with human voice as well for the similar problem. So those who are interested, you can, there is a research paper I've written on this particular thing called Infuse Heart, which was published in IEEE Transactions. And it's very interesting work. So yeah, so this is the work actually. So I designed again a customized framework to detect abnormalities from heart sound. So this is initial level work. And then I carry forward this project to different things. So currently I'm also working with neural oscillations, so mental health along with this, and so there are multiple problems are there in this area. So this is a very interesting area. If you're interested, you can explore this. Only challenge here is a little bit of signal processing knowledge along with AI uh, is required here, because working with signal is a bit challenging compared to just images and videos. But still it's very interesting work which can be yeah. So, and likewise, there are many fellowships are there. So those who are interested for postdocs, there is a Commonwealth Fellowship for Australia. There is Einstein Fellowship for US. And likewise, many Fulbright is there, and there are many more. So it's a good opportunity to visit different universities, research centers, and learn there. So this is one interesting area where which I think that still a lot of problems are there, and solution is not available.
Thank you, sir.
Sure,
Your
sure, sir.
presentation covers everything, almost illustration, case studies, futuristic vision, everything is there. So I once again thank you for sparing time for presentation.
Yeah, thank you everyone for patiently listening, and thank you so much, sir, for the invitation.
Hello, sir.
Hello. Sir,
Uh,
this is Karthik from Tamil Nadu.
Hello, sir.
Sir, from the beginning point, you have to explain air pollution prediction system. So I have some question that part, sir.
Sure.
My first question is, what machine learning models are commonly used for air pollution prediction? And how do you evaluate your machine learning model for air pollution prediction?
So if you're just dealing with this pollutant values, right? Then in that case, you can select simple machine learning algorithms, because generally what happens is, while let's say if I take example of research here, right? Sometimes we write a research paper and we try to select very advanced algorithm, right? Thinking that this will give me good chance for publication. But basically every problem is different. Now it just requires a basic algorithm. So in this case, there are just random values, right? Of PM 2.5, PM 10, NO2, CO, all this. So that's why I apply LR, or just using basic ANN. This problem can be solved. So there is no need of a very advanced algorithm in this particular case, because what you're doing, because here the challenge is not that. Challenge is how to aggregate data of different sensors, right? Then store it on a certain platform, because this data keeps on coming in real time. because how sensor works is it senses from the surrounding environment, and that process happens almost infinite times. So it keeps on happening. You have to aggregate the data, push it on cloud, and then apply machine learning there. So in this particular case study, applying AI is not very challenging. However, uh, classifying AQI into different things is again another challenge. So one problem I can discuss here is I was interested actually, because in future I feel that this might happen that if there are 4 house members right inside house and they are in different locations, they've gone to different locations. If let's say parents is worried, the parents want to see the air quality around their child. Even though right now we might laugh at this, but this would be reality in 4 5 years time. That this climate change is going to take a big effect, and this kind of problems will be there. So that's why I say that selecting the right problem is more challenging than just applying AI there. That's what I felt during my experience and my learning. So air pollution has many problems actually inside. One I discuss about pollution map, but having designing that kind of pollution map is very challenging, because the sensors where you're fitting, the station will only give you pollution or air quality index value for that location of a small area of Modasa. Based on that, you cannot say that in the entire Modasa the same value is applicable. So this challenge has to be resolved. So in air quality, the challenges are a bit different. It's more physical challenges. Designing something like LoRaWAN or or, or IoT based network is more challenging than just applying AI there. And that was the reason that many IoT companies have failed actually. But now with some advanced AI algorithms, along with this, now it's working really well. And after ChatGPT, all these things have come. People have understood that how to combine real time stuff with AI, and that is now replacing jobs and creating a lot of trouble for us. Yeah. Yes, sir. Any more
Yeah,
questions? I'm
thank,
happy to answer.
Thank,
Yes, sir.
thank you.
thanks.
So,
Hello, sir.
Yes, sir.
It's Amnia.
My last
Yes, sir.
question is, visualization techniques are used in air pollution analysis, sir?
So actually, I use 5 different sensors in this particular case, and you can either use any controller like Raspberry Pi, Node MCU, or let's say if you want to run AI code, then you need to go for Jetson or Netson. So there are AI controllers also available nowadays. So basically, these sensors, right, will give you different values. So just like PM is particular method to give you values of dust particles. Likewise, NO, CO2. So these sensors are already available, right? We just need to combine the sensor with the controller, write a little bit of code in Raspberry Pi or Arduino, just to gather these values, and then using some IoT protocol like MQTT, just store it on cloud. Once you have this, so this data is coming like that only. So this particular file which I was discussing, right, like the AQA file I'm talking about. Now the next thing is, because these values are very random values and the basic values. So these values are not actually telling any story. So we have to apply machine learning here for the analysis and for the final prediction, the classification outcome. So that's how. So the physical challenges are there. It's not just combining the sensors. As I told you, how you can say that what is the actual AQI index value for the entire Modasa is the challenge in this particular project. You understand, right? Because every station will give you different random values. So you have to connect. Let's say if I just consider Modasa, maybe 1,000 pollution stations are required just in one Modasa, and then you try to find the mean of that value and tell that okay, AQI value of Modasa is this. That's why it's a very interesting project government has started. Yeah, sure.
This is equivalent to
thank you,
virtual
sir.
sensor.
This equivalent to
Virtual sensor.
Virtual.
no, these are actual sensors. So I can show you that.
Yes, these are actual sensors, but in different area of Modasa. Suppose we are deploying, suppose in 5 areas.
Yeah.
So what we are creating means we need to find the aggregate of these all 5.
So what you can do is people are so if you read research papers, people are doing different kind of experiments. So one researcher, what he has done is let's say you have a car, right? So you put this station on the top of your car, right? Now assume that Modasa is a radius of 30 kilometers, right? So every 1 kilometer you capture this value using the same station, right? So now you have all the values available while moving, and then you find the mean of that, and that you can say that this average EQ value of Modasa. This is one way. Another way is if you know LoRaWAN, right? Because Wi-Fi can cover maximum distance up to 1 kilometer, but there is a concept of LoRa gateway. So one gateway can actually cover half of the Ahmedabad city, or let's say the entire Modasa, one gateway or Wi-Fi gateway can cover. So you have to design your LoRaWAN architecture with this pollution station, means this pollution sensor and the controller, right? And connect that entire area using Wi-Fi. And using Wi-Fi only, you need to push this value to cloud and then apply machine learning. So there are now technology has reached at peak. So many options are available now. If you heard of NB IoT, there are multiple different IoT concepts and architectures are available. But LoRa would be the less expensive solution and the easiest one. And in Europe, in some countries, they already tried this. So I can give you an example. In one of the country in Europe, they actually use a Wi-Fi ATM. So without internet, you can insert your card, access ATM and withdraw your money. So there is no need of internet everywhere, because Wi-Fi gateway is very powerful. It can cover distance of 25 to 30 kilometers. So if you search LoRa, LoRa, I'll just write in the chat. It's very interesting one, LoRaWAN, it's called. And you can actually use this in your experiments. I understand that maybe some challenges with the resources might be there at the university. Same challenge I also faced when I worked at different places, because without resources, it's difficult to gather data, but the sensors are not very expensive. So sensors, you can just get it in just 2,000-3,000, and you can actually carry out experiment on this. And 1 year free Amazon service AWS account is available where you can store data, and a lot of other options are there. So, but like designing a LoRaWAN, you need a LoRaWAN gateway, and the receiver and other things are you need to buy for this. But I'm happy
Okay, sir.
to collaborate
Okay.
for this project if you are interested, and yeah, for sure.
Thank you.
Definitely.
Sure,
Thank
sure.
you. Thank you so much, sir, for
I have
wonderful session. So now actually we have another session planned at the 7:30 p.m. So I request all the participants to keep the questions and put it in a WhatsApp group. We'll get back to you soon with the answers. And
Sure.
thank you so much, sir. Thank you so much, Pandya sir, for joining us and sparing us so great knowledge with us. It's really very informative and hands-on sessions. We have learned more about the air qualities and the where can we apply the air qualities and the futures of the air quality. So thank you so much, sir.
Thank you so much for the invitation.
Thank you.
Bye-bye.
Now,
Bye.
okay, bye, sir. Bye. Now, within let us have the break of 2 minutes, and I will ask second experts to join our meeting. Is it okay, madam?
Yes,
Okay.
ma'am.
I'm
So,
already
okay.
Expert
I'm
is
already here,
Okay.
so let me know when we have to